My name is Benson Hayes. I'm with Fort Collins Water Solutions. This presentation is to summarize our analysis and findings of the Skyline Ditch. Looking at the satellite image here, we can see that there have been two slides which have cut off the ditch here in blue. Due to the geology of the site, the flows are likely shallow debris flows, which are unfortunately very difficult to predict, but I will cover our broad results on this research in the next slide. Shallow debris flows occur in the presence of groundwater infiltration and seepage. These two cases in slope W show, in this case with completely saturated soil, that stability is much more marginal when the pore water pressure is high. Therefore, steps which reduce infiltration are very good guards against slope stability issues in the future.
Burn severity maps were created with ArcMap 10.6, utilizing data made available from the U.S. Department of Agriculture's Cameron Peak Burned Area Emergency Response Map. The two maps visible below represent the Greater Cameron Peak Fire, shown on the left, and the fire localized to the project area, as seen on the right. A LiDAR profile of the Skyline Ditch can also be seen. Legends on each map indicate areas of high soil burn severity, moderate soil burn severity, low soil burn severity, or very low or unburnt soil severity. Overall, burn severity mapping was utilized to estimate acreage for various treatment methods.
My name is Spencer Jordan, and I'll be doing a quick overview of the historical yield data analysis we performed. So that figure there is showing the cumulative diversion records from the Water Supply and Storage Company with and without the Skyline Ditch in use, with the year in red showing the year in which it stopped being in frequent use. And as you can see from the figure, the diversion records after that year significantly increased. The key findings here were that there was about a 3,700 acre-feet per year difference between these timeframes, and that the coefficient of variation increased pretty significantly. And so these findings are supported by the watershed model we performed, which will be discussed by Andrew in the next section.
We created a watershed model using the hydrologic modeling system HEC-HMS. Precipitation loss parameters were adjusted to simulate two basins, one with pre-fire conditions and one with post-fire conditions. The watershed model results are shown below on these two hydrographs. The model indicated a 25% increase in flow from pre to post-fire sub-basin conditions.
In order to ensure that the Water Supply and Storage Company receives the maximum volume of water from the Skyline Ditch, 8 post-fire treatments were designed, priced, and evaluated for effectiveness. These treatments included log erosion barriers and silt fences as pictured on the left, hydro seeding as pictured in the middle, and drywood mulching as pictured on the right. The final post-fire treatment design was broken into 4 categories. For the unburned category, no treatment was needed. For the low burn severity, drywood mulch will be applied. For moderate burn severity, hydro seeding and log erosion barriers will be used. And for the high burn severity, hydro seeding, log erosion barriers, and silt fences will be used.
Finally, we did an environmental research impact study to determine the costs and benefits of each of these final designs. All of the costs associated with our final design for the Skyline Ditch can be avoidable with proper handling of materials and length of logs or duration of the silt fencing. And all of the benefits listed out are important to preventing future landslides and mitigating future fires. Thank you so much for coming to our short presentation. We hope to see you at our E-Days.